Okay, a brief explanation of the law of cosines, because that's better in a video than in lecture. Just the law itself will do the applications in lecture. So it starts with a general triangle, pursuing that project of doing stuff to general rectangles that we've done with right triangles. I mean, general triangles. Triangle ABC. Cut it up with an altitude as before. Give it names. So that's side lowercase a, lowercase b, and altitude h. And then we want to give names to the two pieces of the side lowercase c. So let's call that left side, left part x. And so the right part would be lowercase c minus x, because the total thing is lowercase c, of course. Okay, and then we apply Pythagoras twice. So what we have a square is h square plus c minus x quantity squared. That's the triangle from the foot point of perpendicular of h over to b up to c. And then on the left side, we got triangle AFC. And there the hypotenuse is b. B square is x square plus h square. All right. Cancel out the h. So subtract one from the other. And what do you get? We do that in one go. The way I've done it here is square minus x square is h square, and a square minus c minus x quantity squared is also h square. And so those two things on the left are equal. So we got b square minus x square is equal to a square minus c minus x quantity squared. Expand this out, and it turns out the x squares will cancel. B square is a square minus c square plus 2xc. Okay. Last thing, we want to express the x in terms of ABC and angles. And turns out x is b times the cosine of the angle at A. Make sense? B is the hypotenuse. B times the cosine gives the near leg. So what do we get? B square is a square B square is a square minus c square plus 2bc times cosine A. Rearrange the whole thing a little bit, and you get a square is b square plus c square minus 2bc cosine A. That's the law of cosines. And we'll see applications. Obviously, again, if you have some of these quantities given, you can work out the last missing one. And you can rotate the letters again. But the general pattern is that it very much looks like Pythagoras. So in case you have a right angle at A, that last term is 0, and you just see a squared equal to b squared plus c squared. And the law of cosines generalizes this to arbitrary triangles. All right, that's all there is to say about the law of cosines.